Hello all, welcome to week 3, Data Warehouse and BigQuery. In this video, we're going to talk about machine learning in BigQuery. We are also going to build a model, export it, and run it via Docker. These videos are basically advanced steps for BigQuery. If you're not familiar with machine learning, feel free to skip these videos. Machine learning in BigQuery has a target audience of data analysts and managers. The idea is that you don't have to know any Python or Java. You just have to know SQL and some machine learning algorithms. Another advantage of using BigQuery for machine learning is that you do not have to export the data outside into a different system. Generally, when training a machine learning model, you would export the data from a data warehouse, build a model, train it, and then deploy it. What BigQuery allows us to do is to building the model in the data warehouse itself, and that removes the extra step of exporting the data. Before moving ahead, let's talk about pricing in BigQuery. Pricing would be the actual condition you would have to choose between using machine learning in BigQuery or to build your own model separately. So the first 10 gigabytes of data storage is free in machine learning ML in BigQuery. 1 terabyte of queries processed in a month is free. And if you are using the create model step, the first 10 gigabytes is also free per month. After the free tier, you would have to spend around $250 per terabyte for logistic, linear regression, k-mean clustering, time series model creation, and around $5 per terabyte for AutoML, DNN, boosted trees with extra Vertex AI training costs. These costs are based upon US. If you are in a different region, please check out the cost corresponding to your region. Before taking a look into creating a model via BigQuery, let's first look into the steps involved in machine learning development. The first step is to obviously collect the data, and that's what you have already done before putting the data into BigQuery. The second step is to process the data, do some feature engineering on top of that, obviously splitting the data into training and test set, then building your machine learning model, choosing the correct algorithm, optimizing your parameters, or what we call as hyperparameter tuning, and then validate your model against different error matrices. Obviously, the ML model training and ML model validations will have multiple steps. And once you are satisfied with your model, you will deploy that model. BigQuery actually helps us in all these steps. BigQuery actually allows us to do feature engineering. It also has automatic feature engineering. Then it can already split the data into training and evaluation steps. It allows us to choose between different algorithms, also do hyperparameter tuning. It provides us many error matrices to do our validation against. And BigQuery also allows us to deploy our model using a Docker image. Let's look into what algorithms you will choose for different use cases. This image has been directly taken from BigQuery page, which distributes the algorithms based upon the use case. So for example, if you are predicting values for like sales figures or stock prices, you will use linear regression, boosted tree, AutoML, DNN regressor, or wide and deep regressor. If you want to perform some sort of customer segmentation, k-means is a good start. If you want to identify spams or basically predict between different categories, then logistic regression, boosted tree classifiers, and AutoML tables are good. You can always come back to this image, figure out the use case you are trying to solve, and choose the algorithms based upon that. In this video, we're going to build a linear regression model. I would be using some created SQL queries. I'm going to go through all of them one by one, and you can find all of these queries in our GitHub repo. So you do not need to copy paste them. before we start, let's look into our dataset again. Our dataset of yellow trip data partitioned is being used. We already know the different type of columns there, and we can also check the preview. For my machine learning model, I'm trying to predict the tip amount. The tip amount is generally the tip paid to the driver at the end of the journey. And from my limited knowledge of data science and machine learning, I have chosen some columns. These columns are passenger count, trip distance, pickup location ID, drop-off location ID, payment type, fare amount, and tolerance amount. Obviously, I'm not an expert in machine learning or data scientist. That's why I might not be able to develop the best model for this use case. My aim in this video is to show you the basics of machine learning in BigQuery, to build a basic model and export it. All right, so I have selected my columns and I have chosen a where clause with fare amount not equal to 0. This is done because I have seen that a lot of fare amount is 0, which also incurs into a tip amount being 0. Let's run this. So we can see we have many rows. We have selected the columns, passenger count, trip distance, PU location ID, drop-off location ID, payment type, fare amount, tolls, and tips. BigQuery provides us to do some sort of feature engineering. Let's take a look into feature pre-processing steps provided by BigQuery. BigQuery feature processing steps are divided into two parts: automatic pre-processing and manual pre-processing. Let's first take a look into automatic feature pre-processing. In automatic feature pre-processing, some of the transformations which are automatically applied by BigQuery are standardization of numeric fields, one-hot encoding of category fields, and multi-hot encoding of arrays. There are also other type of automatic feature pre-processing, which I'm not discussing as of right now. If you are unfamiliar with one-hot encoding or multi-hot encoding, you can pause this video and quickly do a Google around it. It basically converts a category feature into a sparse vector. Secondly, let's take a look into the manual pre-processing steps. So as you can see, we have many manual pre-processing like bucketization, polynomial expansion, feature cross, n-grams, min and max scalar. For my example, I did not have to do any manual pre-processing. But if you are more expert in data science or machine learning, feel free to build a model and share it with us. So till now I have selected my columns, but I know that some of the types of the columns would not be fit for automatic reprocessing. For example, the pickup location ID and drop-off location IDs are integers. So is payment type. But they are actually a category feature. They are not an integer. They are basically a category of different payments, like a card or cash, something like that. So what I have done is basically I have created a different table from my columns, but I have casted different columns into string type, allowing BigQuery to do an automatic pre-processing step on it, basically converting my strings into a category feature and using one-hot encoding on it. So I have created a table which is called yellow trip data ML. I have the same passenger count and trip distance. I have converted PU location ID, drop-off location ID, and payment type to string. I have also used the same type of fare amount, tolls amount, and trip amount. So as you can see, I have just added the same columns into my table. Let's run this. All right. So as we can see, our table is generated. It processed around 6.5 gigabytes of data. We have a table with the correct data types, which we can use for our machine learning model. In the next step, we are going to create a model. I have named my model as a tip model, basically because I'm trying to predict the tip. I'm using the model type, or my algorithm is basically linear regression. My input label columns is basically tip amount. This is what I want to predict. And I am using a data split method of auto split. This will split the data for training and evaluation step. The evaluation steps would be used later. So let's quickly run this. It might take a few minutes to build a model. So for me, it took around 5 minutes to create this model. Let's take a look inside it. So we can already see the model type, linear regression. It says that it used a temporary training data set and a temporary evaluation data set. There was no optimizations done. You can already see the loss here, the duration it took, and the evaluation. So you can see that the mean squared error is around 8 and the mean absolute error is around 1. This is not very optimal, but for our use case, this is perfectly fine. This is a simple model dataset and I'm not aiming to build the most optimal model. Next, let's take a look into our feature information. So BigQuery provides us our features. So basically ml.featureinfo will basically give you all the information you require. So we can see that the passenger count, trip distance, fare amount, tolls are all numeric types, and they have been calculated into min, max, the mean, and can be used for standardizations. We can also see that the pickup location, drop-off location, and payment type has been converted into a category, and there are different category counts for them, and so on. In the next step, let's evaluate our model against the training data. In BigQuery, we can simply use ml.evaluate, the model name, and the dataset. So we can see that the mean absolute error is 1, the mean squared error is around 150, and so on. These evaluations can be used for optimizing your model later on. We can now also use ml.predict, which basically will predict our tip amount based in our data set. So let's quickly run this. We can see that there is an extra column coming in, which is basically our tip amount, and we can see all the other columns based upon that. These two columns can also be used for manual evaluation. BigQuery also provides us with the possibility to explain and predict different models. The explain and predict will actually tell us what are the top 3 features used for our dataset. You can also do 4 to understand the top 4 features used in our prediction. Let's quickly run this. And we can see that all our category features are basically being used as our top 3 features. Similarly for the second row, and so on. We have seen that our model was not optimal. We can also do some hyperparameter tuning. BigQuery provides us with many different features for different models. For linear regression, it provides us with parameters like number of trials. Max parallel trials will do multiple trials parallelly so that your query is running faster. L1 regression hyperparameter and L2 regression hyperparameter tuning. There are also other parameter tunings which you can use. If you look into the create model step, you can basically choose linear, linear and logistic regression here, and you can see what all feature sets you have. So we can also have learn rate strategy, rel progress, early stop, learning rate, and everything like that. So this is a rich set of hyperparameter tuning. If you're familiar with machine learning, you can use all these parameters to tune your model. I will attach a link to this file in our README.